programs are there in my desktop which I use. Okay, let's start. Okay, where is my RAM structure? Okay, there it is. This is the one. I believe this is the latest one. It used to look like that, something like that, but now this is the one they have upgraded. So let's click on that. Hopefully it will work. Sometimes I'm not going to cloud services. Okay. Okay, so what you will get is a screen like that, okay? And it's the version 15.03. So just one thing is that if you design it in the latest version, you cannot run it in the older version. But if you design it in the older version, obviously you can upgrade it to the newer version. Okay.
I have RAM structural V8i.
Okay.
Okay, great.
Same. Okay. V8i 64-bit version 15.03.
Okay. The release. Okay.
Should be same.
Okay. Very good. Thank you.
V8i is something for Bentley. Okay.
Okay.
Bentley's most of Bentley's CAD softwares, especially MicroStation, those are all V8i. I don't know what does it mean, but anyway. So before to start with, we need to kind of like a create a new file. So let's click on that new. Let me close your eyes. Don't look at my stuffs. No, I'm just kidding. You can. 438, right?
Yes.
Fall 2016 and lecture. Let's give a name. Building 1. Units, English units. That's what we are going to use. Okay. So if I click that, then my screen will come up like that. So this is my starting point. Every structural model or everything that we will do, especially in structural models, what we have to do is first we have to model it. That means we have to design or we have to draw the model first, and then we can run the analysis, and then also we can design it. Okay. So first what we have to do is actually find out how the building will look like. And anybody has any experience with other softwares like STAAD or ETABS or SAP? Okay, RISA maybe a little bit. Only thing difference between SAP or RISA is that RISA is a frame model, right? You can just say there is a beam and column. There is no decking, or nowadays you can do that, but still it's not like a deck design or floor design. Okay, here it's like complete 3D. You can design the floors, you can design the columns, beams, shear walls, everything. Okay, so that's the difference between RISA and this type of things, and also it designs. So yes.
Sorry. How about SAP?
SAP is actually a model RISA type. It's an improved version of RISA.
Oh.
Okay. The corresponding like RAM, it's corresponding from CSI is ETABS. Okay. So before we move on to that, couple of things that I would like to show. Criteria, member loads. So it's based on the IBC or UBC. UBC was the old version of CBC. Now everything is IBC, so we will follow that. And most of the cases, what we will do is we will use the default. Now, obviously, in your real structure, you need to change them according to your plan. Okay. Roof live loads and so on. Roof live loads are reducible, yes. Okay. So this is the one. Most important is the self weight. Okay, the structure can determine the beams and column sizes, as well as it determines the self weight also. So we do not have to give any self weight. So beams, columns, walls, everything it will calculate. Slabs and decks also. But remember in our class we said, okay, the roof floor dead load is 150 psf. That actually includes the 9-inch or 10-inch slab plus some floor finish. Okay, so usually what I prefer when I'm modeling, I take that off and give them as a dead load, superimposed dead load. Are you following me?
Yes.
Okay, so I'm instead of giving or instead of saying the program to calculate by itself, I give the load as a dead load or live load. Okay, you can do either way. Only thing is, if you ask the program to calculate its own weight, then you have to give the allowance for floor finish and other stuff. Like if you want to put marble, that has a pretty large weight, that has to be added as a superimposed dead load. So I prefer this way, but it's up to you. Okay, let's say that. Okay, now we are ready to go. Other things, what is Bentley cloud surface? That's a new thing. Okay. So let's go into the, either you can go this one or you can click on this one. Both are same. Modeler means I have to model it. Okay. So this is the background. Now nothing is there. So what I need is to set up a background. Background, right? So the background is basically what we will do is we will place beams and columns and floors, shear walls, everything loads in one floor. Okay, we will design the floor to floor base, right? Say for example this is the second floor, we will design it. Then if it is exactly same on the third floor, we will just copy it. If it is different than third floor, then we have to design another one. The easy practice is, I mean, if it is a regular building, not that much variation, we will copy a typical floor. We will model a typical floor and then copy it for different second floor, third floor, fifth floor, something like that. And then we will go there and change the necessary changes, make the necessary changes. Okay. So let's do a typical floor first. Okay. Typical floor means that the one that I showed. If you can see. Anybody has a flashlight? Just flash it there. Okay, that's the typical floor we will do. Okay, and thank you. Okay, that's the one we will do, and then we will copy it for different floors. Does it make sense? So our platform is our typical floor. To draw the to model the typical floor, let's see how we go. The thing that you have to do is click on layout. That means we are laying out our floor model. So layout, and if you see all of these types, grids, columns, beams, horizontal braces, slabs, loads, foundation, you have to go one by one. You cannot jump from here to beams. You have to go one by one. Okay, so that's our chronological order. So first, type. It says select. That means we have to select a platform. Now there is no platform given, so we will say it's a typical platform. Sometimes we will just say typical, and we will add it. So we have added a typical platform or typical floor, and then since it's blue, that means it's already selected, and we'll click on the select. Okay. By the way, if you miss something, please stop. I mean, tell me, then I'll redo it quickly. So don't worry. Stop me as you need. Then this is, if you see, this is my typical. And also, since it's a concrete class, I will change my material to be concrete. You can do it from here, or you can do it from here. Okay. Those who have taken my steel class, you already are familiar with the steel. Steel is the default because RAM actually originally was developed for steel design. Now we'll go back to layout once again. Type. Another things, if you see, select copy, import from DXF files. Like copy is copying separate floors. Import from DXF files, that's very important. Remember, I mean, in the architects will send us CAD drawings. Okay, so if I have a CAD drawing or Revit drawing, what I can do is I can actually import that file instead of doing all the laying out all the floor levels. We can just import it, and it will bring all the grid lines, column lines, beam lines, whatever you need. Okay. Okay, so any CAD drawings which is a DWG, right? CAD drawings and DGN for MicroStation, or I'm not sure about the Revit, RVT. Okay, something. Any of those environment, you can save those files as a DXF file, and if once you have a DXF file, you can copy that, import that DXF file. It will come out in a RAM format. So that's the easy. Nowadays, all the structural softwares are actually linked with Revit or CAD. You can import it and you can export it. Okay, so you do not have to do. Most of the cases, what we do is that architects now more into the Revit, so they send us the Revit file, we work on that, and once we are done, we send it as a Revit file back to the architect, so he can see he or she can see exactly what is going on. Anyway, right now we'll just design it. Now next is we need to calculate, or we need to give a grid system. All of our structural drawings will have a grid. So we'll need a grid. To create a grid, we'll say, we need to give a name, orthogonal. That name came to me when I started as a modeling. That's the first name I got. And I'm still keeping that. It's about like what? Since 2005. Okay, so all of my grid names are orthogonal, the first one. So let's add. And then select this one, and I need to edit grids, which means I need to add up my grids. So X grids is vertical ones, the X level ones. Say I will give them as A. The first coordinate is 0, 0, which is okay. Add. The second coordinate is B, maybe 25. Add. Now if the grids are evenly spaced, what I can do is I can generate more grids, and I can say that okay, let's add another 4 or 5 of them. So if you see C, D, E, F, G, it's already generated. Click on the Y grids, means this ones, and I may be wrong again, every time I am wrong. And the first one is 0, 0, obviously, and I want to create a spacing 30 feet and want to create 7, 6 of them. So all my grids are generated, 1, 2, 3, 4, 5, 6, 7, 7 of them. Grids are generated, and then what I will do is say okay. Now you can change where you want your labels, either I section or I end or J end. If you know, say for example, this is a beam element, right? The way we define in any structural is that we call the first one, the left hand side is I, the right hand side is J. Ith end, Jth end, right? So here it says that your label, grid level, like say this one is 2, should be written as 2 here on the ith end, on the left side. Okay, so let's see. And my grids are already done, so let's say I will do. Okay. Now it's not shown here, so what I need is click on this one, edit grid system. Okay, we already did that, and click on select grid system. So click on that. In my typical floor, I need my orthogonal grids to be shown, and I selected that, and if I click 1, that's my grid. Okay? Any question up to that? Yes?
I would click add, it's not letting me add the multiple AB.
It's generation.
It's not, okay.
Okay? Quickly I'll go back and give you the idea. Grids, select this one, edit, go any of them. If you generate grids, you have to give the grid spacing and give a number, and it will do that. Okay? Does it work? Okay. Okay. Okay, now my grids are selected, so what is my next? Is placing my columns. Okay? before we place some columns, in steel it is very easy because steel designs or steel sections are all prescribed, pre-designed, or it's already given by AIC. For concrete, it's not like that. You need to decide what type of column size, what type of beam sizes you want to give. Okay, so you can check, or you can select your column sizes, or you can define your column sizes. There are two ways of doing that. In prop table, you can say I need my column. You can define column sections and beam sections. So let's give a column section and a beam section before we move on to the laying out of the beams and columns. Okay, is that okay? So column sections, it says C means column. What is a good size? Maybe 20 by 20 or 18 by 18. 18" by 18". Let's start with that. I have to give a geometry which is 18" and 18". Please stop me if you have a question. Okay. Cracked section factor, these are code defined. These are the, obviously this is 1.7 and 1. If you are practicing in California, these numbers are actually 0.5, 0.5, 1. Okay. No, actually 0.5, 0.5, 0.5. Okay, these are the one in especially in seismic zone. Right now we are using the default values. We are not going to change it because these ones depends on what type of building and where you are located. Okay, what type of seismic category. It's a rectangular section, and I will say add. So this one is already generated one section, and I will generate one more section in my property table as a beam section, and I will say beam 12" by 24". Depth is 24", and width is 12". Again, these factors will change. It's a rectangular section, it's not a T section. Right now we have not studied T section, that's why I'm not going to use that. Add. Okay. So I have defined one column section and one beam section, so at least I have something defined. Let's go to the layout. In my columns, my columns will be mostly in those intersection of grids, right? So that means it's on grid. So if I go layout, columns, add on grid, and it will come with a dialog box like that, standard column. Okay. Framing, right now I will start with a gravity framing. Later on I will change some of them to be lateral columns. Okay. Orientation, it could be this way or inclined angles, whatever you want, that's fine. Since we have an 18 by 18, doesn't matter whether it's vertical or horizontal. Normal weight concrete, obviously I need something which is regular. Reinforcements are 60 KSI steel. F prime C 4 KSI. Unit weight 145 KSI, and self weight is 150. So there is a slight difference. We use 150. Poisson's ratio 0.2 is fine. So you can go and select single. If you see, it will snap on the intersection. So if you click on those, it will snap them. Now it's pretty much time consuming. Okay, well, not that much, but still. So if you go right click on your mouse, the same dialog box will come back. And instead of single, you can say I will do it as a fence. So click on that. Fence it, it will place columns everywhere. Okay, all intersections. So my columns are placed. So one thing you can do now is give a column size, or you can do it later, doesn't matter. So maybe column, I can assign a size. Now a lot of columns you can change properties that I will show you. You can delete columns, change materials. You may want to add something in the middle, you can do that. So let's do assign size and standard column So all my columns are already assigned, the shape or the size. Okay, I want to give now a little bit on the beams. Next item is beam. Again, my beams are what? From column to column. So I will say add on grids. Gravity and things, these are all almost same. What I will do is again single first. And if you see, it snaps on the column to column. So you can do that. Okay. Or you can say that I want to do it faster, so right click and you'll do a fence, and if you do like that, it will generate or it will place beams between column to column. Okay, are you okay with that so far? Okay. Those who are new, in the sense that those who have not taken steel, that means that this is the first time you are looking at, right? Okay, so please do stop me if you do not follow. Okay, some of the students, a lot of other students, they have already taken steel, so they already know that. So please do stop me if you do not follow or something is you cannot understand. Okay, yes.
How do you get to the grid?
Grid, go layout, grades, create an ID.
That's what I click and then nothing shows up.
Oh, you are not showing the grids.
Yeah.
Click on this one. Okay, go orthogonal.
Oh, okay.
It should show grids like that.
Okay.
Why my grids are not shown?
Because I covered them.
Now it's shown. Okay, once you have the now I want to do a little bit trick, not a trick. Remember I said that I will make this layer, this row with multiple beams, so that I have actually a one-way slab. Okay, so what I will do is, how I can do, I will place one beam here and one beam here. Right? So if I say go beam, add off grid, that's one way of doing. Add off grid, it will come up with like that. And what I will do is, I will say that I will click on that, it will come all those, and then click on the delete. Cross means delete. Delete, single. Okay, good. Okay, so my beams are done. I can again assign the beam sizes. Again, if you click on that, you can, where is the assignment? Assign beam size, you can do that, or you can go layout, beams, assign beam size. Remember, we already generated one beam size, and if we say fence for all of them, it's already designed. Now if you want to know whether it's designed or you assigned it, click on this button, which will show all the numbers. Be 12 by 24. Yes.
Okay, do I click single or fence?
For assignment,
Yeah.
you can do both, either single or fence, depending on what type of. I mean, in real life, real structure, we will have like multiple beam sizes. So in that case, probably single would be better. Right now, we are just using a general one, so just use fence. Okay. If I click again, it will go away. Okay. Now my beams are done. Also, if you click columns and then click on that, it will show me, where is my column? Oh. It will show me in my plan view actually, sorry, elevation view. Anyway, so far I have laid out the beams and columns. Horizontal braces, those are actually required mostly in steel structures, not in concrete structures, because in steel structures your deck is actually in one direction, so in other direction you may have a weaker zone where you have a moment frame or something. So in those cases you need horizontal braces. For concrete you do not need. Okay? Walls. Do I need to add walls? Yes, it's a concrete building, so probably we will have a lot of shear walls or some shear walls. So let's add some shear walls. Okay? Now, before you add shear walls, say for example, I want this block to be whole shear wall, maybe another 2 blocks of shear wall. Okay, 2 shear walls, and 1 block or 2 blocks of core walls, means elevator cores. Okay, usually elevator in a concrete building, elevator cores are made shear walls, so that solves my problem. Now, only problem with the shear wall is because it's a shear wall, you cannot have a big opening in your shear wall. So if it is in the middle of the beam, if it is in the middle of the building, you are blocking the building. Okay, you cannot move from one place to another, or you cannot have lights going through that. So that's kind of like a problematic sometimes. Okay, so what we do in those cases, most of the cases you will see that elevator course does not need any lights to go inside. Okay, and it does not allow, it does not need you to do anything on that. So most of the elevator cores in a concrete building are shear walls. Okay. Also, for the modeling purpose, when there is a shear wall, you do not need a beam, or actually shear walls are beams. So what we will do is, let's say we will make this one as a shear wall. So in here we will erase or delete all the beams. So go to beam, delete beams, single. So these are the beams deleted, and what I will do is I will make these 2 lines as my shear walls. In this direction I will put moment frames. Okay, so I am giving one direction shear walls, one direction moment frames. So let's place walls, add on grid, and add on grid, it will come up with the 10-inch thick wall, which is fine, whatever thickness you want. All of these are fine. Only thing is, usually shear walls are lateral resisting system. Okay, those are for earthquake. So I will create or click on the lateral. You can use a single. If you click single, it will again like that. Or you can say I will do a fence. Now remember, when it is a lateral system, it will come up with some sort of red lines. You can see the red lines outside the wall, right? Can you see it? Again, I will do this one. So, if you see this building, it's very kind of like a very strong against this type of, in this direction movement, lateral movement, because it has shear wall, shear wall, shear wall, shear wall. But in this direction, it's not that strong because it has only 2 shear walls, but there is nothing else. So what I will do is I will make some moment frames. How do I make moment frames? only thing that I need to change is this column, this beam, this column, this beam, and this column, sorry, this column, this beam, and this column. Make them as lateral rather than gravity. Okay, how do I do that? So let's do for beam columns, let's say go to layout, columns. Now what I will do is change properties. Click on that, it will come out with a dialog box like that. Standard column fine. In my framing part, I will say that, click on that, and from gravity I will do lateral, and I will do a fence so that I have these 4 columns which are lateral. Again, as I said, any lateral members will come up with a red line. That means it's lateral, and I will do these 2 bays also in the other direction as moment frame. Okay, there is something hidden, I'm not saying it because I want my building to move very symmetric way, so that's why I'm trying to give something like that. Columns are given as lateral, but I need to give beams also. So go layout, beams, change properties, and framing, make them lateral, fence. Okay. So far, are you okay with that? Okay. Now what is next? Go layout, beams done, braces done, walls done. Okay. Slab. Okay. So for a slab, first what I need to do is I need to define the location of my slab, the perimeter of the slab. Okay, or perimeter of the slab, or what we call slab edge. Slab edge is that this line represents my center to center, that means center line of my beam. Slab cannot stop at the middle of the beam. It has to extend the end of the beam and a little bit more, right? So I will extend it at least 12 inch more from the center line of the beam. And you can go one by one, or you can say I will do the whole perimeter. If you click that, there will be a green line outside. If you look into that, this is your center line, this is your slab edge of your slab. Okay, so I define the perimeter of the slab. Now I need to define the slab itself. Okay, assignment. Okay, but before I assign the deck or the perimeter of the slab, I need to know, since for example this one is an elevator core, so there will be no slab here, right? Right now if I lay out the slab, everything will be with the slab. So what I need to do is I need to define a punch or a hole in my slab. So let's go layout, slab, slab opening, and I will say I will go from left. Slab opening, that means the edge of the slab should be inside, not outside of that opening. Okay, and what I will do is I will go at, let me zoom it in. It will always snap on the intersection. There is an orange line inside, that means it's okay. If it is going on that side, it will give you an error. Slab opening has to be inside.
What is left?
Left means I'm going, my overhang is on my left. If you go left, means my overhang, when I'm going from here to here, the overhang portion should be on my left. If you go right, overhang should be on your right. That's wrong. Okay? Opening is there, so what I need now is define the deck itself. Okay? Only thing that is wrong with me is that this one-way slab. Okay? So in this part, what I will do is I will delete this one-way slab part and I will make everything two-way. Okay? Or what you could do is make two-way all of them, and only this portion you can make it as a one-way. You can do that. Okay? I don't have the time to do that. Okay, that will take time. So what I'll do is I'll delete these beams to make it 2A. So layout, slab, deck assignment. Now deck assignment, I have no deck to assign. So what I need is to go back on my property table and actually define a deck. Okay. If you see, concrete slab, label, say floor. Usually what I do is 30 by 25. It's a 10-inch floor. So I will say floor 10. Thickness is 10 inch. The other things I'm using the default values, and I will say use
How did you get to that window?
this one. Property table, decking, and it's a concrete floor, so I will say floor 10 inch. 10, it's a label, it's nothing to do with the 10 inch. 10 inch you have to leave it here. I will say add. So, okay. Now it's defined. Okay. Now what you can do is go slab, deck assignment. It's already there, and all you need to do is either you can say floor or you can say whole diaphragm. What is the difference between a floor and a diaphragm? I mentioned it in the class. It's the same. Floor and diaphragm are the same, placing or existence wise. Floor is basically taking the gravity load, diaphragm is basically taking the lateral load, but the same thing. This is taking gravity load, this is taking lateral load also. When we say that okay, it's taking the lateral load, we'll call it as a diaphragm. When it is taking gravity load, we'll call it floor. So it doesn't matter whether it's a floor load or diaphragm. I personally like to use it as a diaphragm. So I clicked on that, and if you click inside the diaphragm, it will come up like that. Okay, so my floors are done. Now all the geometries are given. More, only the foundation cells left. Yes. Question? Okay. Only the foundations, but I have not specified any dead load, live load. So what I need to do is go back to property table, okay, and I need to define some load. Now there are a couple of loads or different loads. You can use surface loads, that means PSF loading. You can use line loads, mostly those line loads are wall loadings or something. You can use point loads, basically if you have a machine or something, huge load, you can say as a point load, or you can use snow loads. Obviously it's on the roof. Also snow load comes with the drifting issue. If you know that drifting, that means if it is on the roof and if you have high wind, the snow stacks on the sides of the wall. That's much dangerous than putting up in the wall. A common 1 feet of snow. Stacking is about like 5-6 feet. So instead of making our life complicated, we will say we have a surface load. If we click that, it will come up like that, and I'm saying that this is my floor. Now remember I said that I do not want my slab to be calculated by itself, by the program. I want to give the load, right? So 10-inch slab is 125 PSF, if you remember. 10 by 12 multiplied by 150, that's 125. Plus another 25 PSF for a kind of like a finishing, marble or whatever you want. Okay, so another 25 makes it 150 PSF dead load. Construction dead load. What is construction dead load? Construction dead load is when you pour the concrete, fresh concrete, it has the self weight, but it cannot take the self weight, right? It has the self weight, but it cannot do anything because it is not stiff enough to take that. But somebody has to take it. Who takes it?
No.
For a concrete, the shoring will take it. Okay, shoring or all the shutterings or the formworks there, that will take it. In steel structure, since you have a steel deck, the deck will take it. You do not need any shoring. So construction dead load is more important in your steel design rather than in concrete. In concrete, it's basically you have to have a shoring. There is no other things that can take it. So construction dead load will be about slightly less than 150 psf because you are not considering the floor finish yet because it's wet concrete. Once it's hardened, then you can apply the finish, okay, the marbles or anything, tiles. Right now I'm just using the same number. Okay, again, usually if his dead load is 150, your construction live load should be 125. Well, why not we do that 125? Live load, it's a floor, so maybe 60 psf, office 50 or 60, right? Let's use 50. Is that reducible? Yes. If it is at the roof level, you can click on the roof, then it will reduce according to the roof's equation. Partition. Those are all partition load, these walls. Okay? Those are all partition walls, so usually what we do is partition walls are not kind of like a shown. It's partition, that means it's a temporary. You can break it and move it somewhere else. So the way we do it is that we assume that it gives a uniform load on my floor. So usually partition loads are 10 psf. Okay. 10. Construction live load. What is construction live load? During the process of construction, you will be walking on top of your slabs to check the reinforcements and so on. So we like to add some live load on that. Usually that's 25 psf. Okay. Mass dead load, which is basically required for seismic calculation or seismic force. And mass dead load is actually your dead load plus if you have a partition which is half of the partition load is actually assumed as a mass dead load. For our case, we will use just the dead load 150 to be our mass dead load. Okay? And if you see, it will calculate beams, columns, walls weight, but not the slab weights. Add that one. So your surface load is done. Say okay. Maybe we'll do a line load also. Because all of our buildings, not surface, all of our buildings needs to have an skin, exterior skin, and we will say that that's wall load. Dead load is 0.18 keep per feet. And remember, it's keep per feet. Usually, if it is a 12 feet load, these walls are 15 pounds per square feet. 1 square feet is 15 pounds. Multiplied by 12 feet high is 180 pounds per linear feet. 180 means 0.1 keep per feet. Okay? Depending on your building height, your wall material, you can change it. Okay? Common practice is this one. Construction dead load, we do not need that. Live load, that doesn't have anything mass dead load. If you want, you can add that. I'm just not going to add anything. Okay. Say okay. Other ones you can define if it is required. I'm not going to do anything. So now I have defined the loads, but I have to place them. So go to loads, surface load, select this surface load and say whole diaphragm. Change, color change means it's already applied. Did you follow me? Okay. What about the line loads? Okay, go layout, loads, line load. You can use the wall load and I'll say that whole perimeter. It's already there. Defined?
Can you say that again?
The wall load.
The line load?
Go to layout, loads, line load. Select the one and then say whole perimeter. It's not whole foot, so it's whole perimeter. Okay, it's already there, don't worry. Now two things, I can give the foundations now or I can give the foundations later. Okay, my loading is done, everything, more or less everything is done. Okay, are you okay with that? Okay, now what I need to do is I need to actually generate the different flows. Okay, so basically what I will do is go layout and type again the first one and select, click on that again. Two things I will do, I will add a roof and I will add a floor, add a first floor. Why usually I do that? Because roof live load is different and first floor live loads are also different. Usually first floor, if you have corridors, that is 100 PSF rather than different from other floors. Okay, and also first floor height is usually 15 or 18 feet compared to regular height of the building, regular story heights. Okay, so I will add one first floor, and also add, and I will add one roof. Okay, on my first floor I will say that okay, select, since there is nothing given on my first floor yet, nothing defined, what I'm going to do is I'm going to copy everything from the typical floor. Does it make sense? Okay, so again go to layout, type copy now. So if you click the copy, it says copy from where? Copy from typical, and I will say everything copy. So copy everything. Also, instead of going layout, type and select like that, what you can do is you can just go and say roof, and again if there is nothing, all you can do is copy everything from the typical like that. So only thing that I'm not going to now, if you go on to the roof surface, you can change this load and it says that roof, everything remains same, only thing I will say that 20 PSF and the roof is at roof level, add, and I'll say okay, and then layout, loads, surface load. First I have floor load, actually delete that, show, delete, it's done. Right click, now add roof and change it. That's why I did that. First floor, I'm not going to change any load. Only thing what I'm going to do is add the foundations on the first floor. Okay. If you add foundations on the typical, that's also fine. It will actually show the foundations on the bottom of the first floor. Yes.
What's the load for the roof surface again?
Roof surface. Dead load is 100 and live load is 20 PSF, and it is roof live load, that means it's reduced according to the roof equation. Okay. Now I will go to the first floor. Okay. Loadings are changed. Only thing what I'm going to do is add foundations. So go layout, foundations. Each of these gravity columns will have a single spread footing. So single column footing, add. I'm just going to use the same thing. You can use single. Use single. Click on that. It will show a column foundation. Right click. I'm going to give a fence. If you look at that, I'm not going to put up any foundations for any lateral systems. Lateral system, it's very hard to use a single footing and survive with that. Okay, so these are all my gravity columns. I forgot one thing. Sorry, I should have mentioned. My walls, these columns needs to be lateral also. I forgot that because somehow I did not go. So go layout again, sorry for that. Columns, change properties, framing lateral, fence. You need to give them basically. Sorry for that. Technically, these columns are needed for modeling purpose, not for regular construction purpose. Those are actually boundary elements. How much time do I have? 15 minutes, right? Half an hour actually. The next class is my class. So. Okay, so now I already gave some foundations, right? So let's go to the foundations again. Now for the lateral members, I will use continuous foundations. And I will say it's a continuous foundation. Sorry. Now, don't get frustrated because, well, I've been doing it for long, so I'm a little bit faster. Okay? You will be like that, don't worry. In a couple of years. Okay. So, more or less, my foundations are given. I should have given one moment frame in the middle, but anyway, that's okay. Let's save it. I haven't saved it for a long time. Okay. Okay, so my layouts are already done. Now what I need to do is actually see the building itself. Okay. Right now there is nothing on the vertical system, so what I will go is go to story and now define. Story first floor. First floor is first type. Is that my computer or somebody else's computer?
It's mine.
Okay. And first floor I will give a 15 feet high. And there is no splicing. Splicing means if you want to change the column size. I don't want that. Second floor is second. I will make the height 12 feet, but it's a typical floor, not the first floor. Right? Are you really cold that much? Are you okay? Yeah? Okay. Third, typical, no splicing, 12 feet, add. Fourth, typical, yes, I need a splicing, add. Fifth, typical, no splicing, add. Sixth, make it roof, no splicing, add.
Quick question.
Yes.
After how many feet you need splicing?
No, usually I try to give 3 floors as a single. For a concrete beam, concrete building, you do not need to give any splicing. If you want, you can have the same column size. I mean, obviously, after 3 floors, the loads will be not that high. So that's why I changed the. But in a steel, yes, you have to have at least 3. After 3 stories, you have to have the change, because that's where you're splicing. Steel columns cannot come like 60 feet. So far okay? Okay. Let's see whether it's okay. Done. Click on 3D view. Let's see. Good. That's my building now. Good? Looks good? Okay. So the back and front arrows, you can move them. Have you seen those commercials? Building, I'm not sure. There are commercials which actually shows like that. Okay? If you want to see bottom from the bottom, the foundations and so on. Okay, so this is our building, 6-story building. You can see the shear walls, gravity columns, those ones. One thing I strongly suggest you to check whether you're any problem with the model. So go to the integrity, data check, go for an integrated, that means gravity and frames, everything. Click OK. No errors, no warnings, so far it's okay. If there is an error, you cannot actually move or proceed. So you have to fix that error. Okay? That's where I will come to play in your model. Okay, let's save it. So far in 1 hour we are done with our modeling. Yes.
For that orange looking box for the lateral load or something, the one on the walls, if you messed up, is there a way to delete it and then redo it?
Yeah.
Because I drew mine too short.
Mess up with what?
Like I only went from 6 to 5. I didn't go from 6 all the way to 3.
Doesn't matter. Leave it like that.
Oh, okay.
Okay. This is for. But what you can do, 6 to 5 is fine. What you need to do is go to layout and make the columns, change properties, and click on those columns which are not lateral. And same for the beams also. Okay. Okay, let's move on to the designs now. We are done with the modeling, and you'll see there is a green light. For concrete, this is your concrete design module. Click on that. Which one? I cannot show it again. No, I'm just kidding. Click on this one. Okay, it's concrete design. I get excited. Okay, mode. We have to do the analysis first and then do the criteria. Let's check the code. We are using ACI 318-11. That's the latest for RAM. They have not adapted the 14 code. It was just released in June, I believe. So give them another 3 years. They will have that. Okay. So we will do that. Other things for the analysis, we'll do that. Right now what we need is the analysis. To do the analysis, let's see, we'll just use default. Okay. Column forces, we'll just set default. Side sway, default. Effective length, default. Bracing, slab braces columns, yes. Assign column size. We already assigned column sizes. Okay, we do not need to do that. Or if we did not, we can do that. Effective length, we can do that. And I will say that just all. Beams. Yes.
Question. Sorry, going back a few steps. I don't have a green light on my RAM modeler.
Green light. Did you check integrity check?
Sorry?
Did you do the integrity check?
Integrated check. In the model?
Yes. I can show it to you after the class.
I'm green now.
Okay.
Thank you.
You're green? I'm always green. No, just okay. Assign column, we did that. Beam, we did that. Fixity, it's already default, but again we can do that. Assign beam lines, that's very important. You will say automatic, and I will say automatic. That means it will consider this whole one as a beam, this whole one as a one beam. So it's a continuous beam. Okay. Process. Let's analyze it. So analyzing it takes some time. Tom, stop talking. Okay, analysis is successful. Okay, so analytical part is done. Now, if you want, you can go and find out results. If you want, you can. One thing I want to show you, the FEM model, mesh, say 4th floor. That's how it does. Have you heard the name finite element methods? It does use finite elements. Okay, so that's how it is meshed and so on. Okay. Now I need to do beam designs. So gravity beam design. So I'll go concrete beams, and again criteria, frame type, ordinary moment frame is fine right now. I will just use the defaults now. Reinforcements for longitudinal, that means the main bending reinforcements is number 5 and above. If you want, you can, and for transverse, which is the ties, the stirrups, is number 3 and number 4. You can read those lateral beams, how much top layer, bottom layer. Bar selection, minimum number of bars is 2, minimum number of bars at the bottom is 2, obviously 2 and 2. Same bar, keep all bars in the layer same size, you can do that, or you may say different, that's up to you. Design checks, it includes 2 additional checks, one is the torsional check and the other one is deep beam check. Okay. Remind me in our regular class what are the torsional checks and deep beam checks. You will see that all the edge columns or edge beams will fail due to torsional. Okay. Assign beam detailing. This is how it will detail again. It's a complete thing. Minimum number of continuous bars on the top is I will make it 2. Okay. This is a column support, so where they want to place bars and how they want to place bars. This is what it is. Lateral beams, usually I will give 2 also. Okay.
What does it mean by gravity joist? What is joist?
Gravity joist is basically, joist is actually on the roof level, especially if you see T-beams, those are joists, also called joists. Okay? Those are like a setting up there, not like a continuous connection. What is that? Okay. Assignments or deflection, I'll just use the default values. Okay, camber, I do not need camber for concrete. Assign size, I already sized it, again I'll just click again. Assign reinforcement layouts, I'll just click all of them and say all. Deflection criteria, I'll just use the default. Combination, generate the combination. Obviously ACI 318, live load factor of the roof. I'll just click generate. It will generate all the live load cases. Load combinations. Okay. If you want to do some custom ones, you want to add your own, you can do that. Say for example, concrete ACI, you can do that, and same thing, it will come up with the same one. Yes, Becky.
I have one question. For designing beams and columns, do we need to include seismic load combination into our design?
Yes, these are gravity designs now. When you are doing the say shear walls or moment frames, you need to have a seismic load combination. That's I'm going to show you in about if I have the time.
Okay, thank you.
Okay, let's go design off. Design complete. Okay, so fast. Not bad. Actually, it's not bad. Okay, let's see one of the beams. Maybe this one. Okay, this is too small. Maybe that one. Okay. Longitudinal reinforcement, 2 number 6 on the top, So if you see 2 number 6, this one, longitudinal reinforcement, top reinforcement. 3 number 6, 2 number 7. Okay. Now remember, I did not change the I said that you can use whatever size you want. If I clicked on that, use the same bar, then it would be 3 number 7, 3 number 6. Top reinforcement, bottom reinforcement. 2 number 6, 2 number 5s, and so on. Okay. And look at the spans. This is the moment, this is the reinforcement. This is the moment, this is the reinforcement. Again, top, this is the moment, this is the reinforcement. And also transverse. 5 number 3 at 9 inch on centers. 9 number 3 at 9 inch centers. 7 number 3 at 9 inch centers. All your shear reinforcement, the stirrups. Okay. Now these stirrups are actually 4-legged stirrups instead of 2 legs. Okay. So you can change it. Design warnings, so far there is no design warning. Deflections, you can calculate the deflection. I mean, it's already given you the deflection. Section material properties is fine. And you can see it is grain, that means it's okay. Okay. So your beam designs are done. All of the beams are designed already. Oh, what did I? It takes a long time to save them. You can take a nap, yeah, that's true.
That's done.
Oh, done. Oh, not bad. Okay, let's do the column designs now quickly. And if we have another 10 minutes, I can show you, Becky, I can show you that for all of it. For the column designs, okay, criteria, frame type, I'll use the same criteria. Column designs, bar selection, you can check that out. Design checks again, torsional and maximum column axial load capacity for IMF and SMF. Column lap splicing, remember I talked about 36D and 55D lap splicing, that's what it is. Assign size, we already sized it. Shear legs, just use the default all. Bar patterns, now I need to define bar patterns. So click on the edit. There is no bar. This would be column. 4 top face, additional bars, 4 of them, 2 of them. Because our column size is 18 by 18 inch, so each side will have 4 of them, right? 4, 4, 4, 4, so which is about 12. Minimum longitudinal bar number 5, that's not acceptable, it has to be number 5. And maximum number longitudinal bar is number 4, that's not acceptable, either number 10, 11, whatever you want. But that's number 5 to all the way up. Transverse bar size are the ties. If it is number 11 and above, the longitudinal bars, you need to number 4 bars. Okay, if it is below number 10, you can use number 3 bars. That's why I used number 10 bars and number 3 bars. Add, it will come up with this number and we'll say okay. And then define bars, click on that, that means you selected and you selected for all of them. Okay? Load combinations already generated, I will use the same one. Process, design all. Now remember that for my lateral frames, they also take gravity loads in. They are not only for lateral load taking purpose. They take the lateral load on top of gravity loads. I mean, they have to take the gravity loads plus the lateral loads. Done? Okay. So if you see, there is no red flag, but there is orange flag. That means it's almost like close. Let's see one of them. I think that's a red actually. This one is a red, right? Yeah, it is a red. That means 18 by 18 with the same bars, it's not going to warp for that. Okay, you need to make it 24 by 24 or something else with more reinforcement. Okay, this is red, means it not work. How about this orange one? It's green, means it's work. 12 number 5s, 12 number 5s. Okay, and capacity is this one, and its maximum moment capacity is 104 kips. Axial load, maximum moment capacity is 130. This is the load combination. Okay, and it can take it. So your design, column design is 18 inch by 18 inch with 12 number 5 bars, number 5, all 12, and your transverse reinforcement is number 3 at 6 inch on centers. That's it. So you have done the beam designs, you have done the column designs. Now, obviously there are some red flags. You need to have a larger one. Let me go quickly to the laterals one. Once we are done with gravity, beams and columns, we will go to the lateral frame and then come back for the shear wall design. Because shear wall designs are not only for gravity, they are actually also for lateral. So I have to go, click on that. It will come out like an orange one because shear walls are not designed yet. So don't worry about that. Frame, that's where our lateral designs or lateral analysis will be done. So click on that, frame. This is where our seismic load or wind loads are going to be applied. Most of the cases you can run, these are not the ones, only the basic one that I would like to show you is the loads, how we give the loads. For loads, load cases, the RAM itself can take or calculate the live load, seismic loads based on ASC 710. That's the latest code we are using in California. Sorry, 710 equivalent lateral load. Now, for high-rise buildings like a 6-story, 7-story, we would be actually doing a dynamic solution, not a static analysis. That's not permitted, but we'll do that. And I'll say seismic, okay, add. If you want to take a picture because that's one you need, the numbers. Okay, shear wall, 6 is fine. Moment frame, okay, our moment frame is in the y direction, it should be 8. Special moment frame. Importance is 1.25. Sorry, shear wall is actually 6.5. Soil site class is D. SS value is 1.93 for Northridge. That's the seismic coefficients that I'm placing. 0.69. These two numbers are specifically Northridge numbers coming from Geological Survey, USGS map. Building category 3. Other than that, I do not need to change anything. Only thing I need is consider orthogonal effects, because remember orthogonal means I have two lateral system coming at a single point. I have my shear walls coming in, closed shear walls, they are coming in at the same time, so I have to have a orthogonal condition. Click OK. It will generate 16 load cases. I will also give a wind load which is based on ASC 710, which is quick. And exposure B or C, that is fine. Only thing, I do not need anything because they changed the wind speed to 110 miles per hour. 3 years back it used to be 85 miles per hour. Now they changed it. It generates again 16 load cases. Say okay. Once my loads are done, all I need is analyze. Select all the load cases and do an analysis. That's where I would like to show you a dance of my building. How the building will dance. You're not familiar with the dancing part, right? They are familiar. It's not a tap dance, right? What kind of dance is that?
bit
Is the
more of a
building gonna dance or are
hula.
you gonna
Huh?
dance?
Hula?
Hula man.
Huh?
Are you gonna dance or is the building gonna
The
dance?
building is going to dance.
Oh. Not as cool.
A concrete building takes a lot of time. Steel building is very fast. Okay, done. Maybe this way. Okay, so process, results, deflected shapes. Okay, I'm going to use maybe this one. Worried? This is 200 times. Okay, don't show the contours. Okay. The interesting part is, I want to show one more thing is, let's take out the way we apply is mostly what we would like to see is how the lateral members are moving. Okay, so if you see where is that? Yeah, our process, analyze, deflected shape. Okay. If you see, more or less uniform in the Y direction, earthquake in the X direction. Sorry. Again, more or less uniform. Okay. So that's what we want like to have our building. Move uniformly, not like a twisting one. Okay. Let's go one more for the wind. Let's see whether wind applies. It's actually moving, but you're not seeing it. That means the earthquake is way too much larger effect on this building than that building. Okay, but for the shear wall design, you need to talk to me. Okay, because that will take another 2 months. Any question? I'm done. How was the movie? Good?
Yes.
What for $13? Did it work for you? I mean the loading? Okay.
No, did my laptop turn on? Can you scrutinize my building? Oh my goodness.
Yes, I remember that.
It's a good design, right?
That's good.